Okay, guys, I forgot to record the lesson, so this is take 2. It might go a little bit quicker, but you can always ask questions tomorrow. Okay, so this is section, we're going to go back and talk about parts of 2.3 or I'm sorry, go back and talk about 2.2 and then do a few things with 2.3. Okay, yesterday was 2.3, the rules. And then 2.2, we're going to go back and just talk about a few things. So we'll kind of put those together. So we're going to talk about derivative rules. And then we're also going to talk about derivatives, derivatives and slope. We know that derivatives find the slope. Those two things kind of go together. Right? Not kind of. They go together. All right, so let's take a look at this problem, right? The equation of the tangent line at 3, 4 for f of x equals x squared minus 5. We did this problem the very first day. We did this problem the very first day using limits. Now we're just going to take a different approach. Okay, we don't have to use limits, which is kind of nice. But I want you to realize this is the exact same problem that we did the very first day. But we don't have to do all those limits because now we know the shortcut for slope. So the shortcut for slope is what? Roll it down, subtract 1. So roll it down, subtract 1, and the constant goes away. If we did all that limit stuff the first day, this is what we would have got. Now we can plug in 3. So our slope is 2 times 3, so our slope is 6. And then we go to y minus y1 equals mx minus x1. So it's going to be y minus 4 equals 6, x minus 3. And then that's fine for me. Distribute y minus 4 equals 6x minus 18. Add to 4. And so we got y equals 6x minus 4. Same thing we did the first day, but now instead of limits, we can just apply our shortcut rules and get there a little bit quicker. Okay, it's like, yeah, Monday we took the regular road, right? And then today we took the toll road. Got us there a little bit quicker. Okay, but the same problem, same exact answer. It's just the path that we took is different. Okay. All right. Now, let's step it up a notch. So these problems are going to be a little bit harder, so it's going to be nice that we have the shortcut. These problems are just a little bit harder. So let's do, sorry, on these you guys got to write them out. I should have typed them, but okay. Find, now notice these directions. Find the points. Find the points on the curve. Find the points on the curve, and here's the curve. Here we go. Y equals 4x to the third minus 18x squared minus 120x plus 5. And then we wanted where the tangent, is horizontal. Okay, any graph, this one probably looks like the one I'm going to draw, but it just in general. If we have a graph, where is the tangent horizontal? And what do we know about horizontal lines and their slope? Because everything in this chapter and the next chapter is going to be dealing with slope. You can always ask yourself, okay, what do I know about slope in this problem? Well, we know that horizontal lines have a slope of 0. Okay? So just visually on this graph, can you see that there's a horizontal line here, and there's a horizontal line there, and their slopes are 0. Now, we're still going to find this derivative. Okay, we're still going to find this derivative. So we're going to roll it down and subtract 1. Okay, so we get 12x squared minus 36x minus 120. And the derivative finds you slope. So I can replace this with n, because the derivative finds you slope. Okay, but we knew slope all along. We knew slope. So why did I find the derivative? Well, I know that my slope is 0. But I'm looking for points, which means I need x values. So can I solve this equation and get an x value? Because that'll be the x values where my slope is 0. Okay. How do we solve a quadratic that's equal to 0? You factor. Okay. This one, the first factoring that I would do is take out a 12. But should I say that again? I need points, so I actually need the x values when I know my answer is 0. So I have to solve this equation for x. It's a quadratic, so I have to factor. So it makes sense that I'm actually solving for x here and nothing like an m, because I knew my m, and I'm looking for points, which are x's and y's. Take out the 12, x squared minus 3x minus 10. Divide both sides by 12. You don't really need that. 12. This will factor x minus 5 and x plus 2, which actually means my x values. Okay? Now, there's a difference between factoring and solving. We got that wrong on the test. This is factoring. If I actually have to solve, then my answer is positive 5 and negative 2. So that means my answer is, oh, and on the homework it says put the smaller one first. So that's just because that's what the homework says. 5 or negative 2 and then 5. Now I need my y value. Well, to get my y value, I just simply take this negative 2. It's a point on my graph. If it's a point on my graph, remember that's always my curve or my graph, or both like to call it curve, but curve or graph. If it's a point on my graph, then I simply have to take the negative 2 and plug it in. You just have to take the time 4 times negative 2 cubed minus 18 times negative 2 squared minus 120 times negative 2 and then plus 5. So that's just a matter of typing that into your calculator. Let's see. Somewhere I might have it. I got 141. Okay. And then same thing with 5. Notice it did say find the points. 5 and negative 2 is not a point. These are 2 x values, which then will produce 2 y values, or 2 whole points. Okay. So then I take the time to plug the 5 in, 4 times 5 to the third minus 18 times 5 squared. You see I'm just literally plugging it in here. So I'm next going to say negative 120 times 5 and then plus 5. Negative 120 times 5 and then plus 5. And so my other answer is 5, and then it should be negative 545. So I found these 2 points, depending how accurate my graph is. There was 2 horizontals though, negative 2, 141, and 5, negative 545. Okay, let's try one more. All right, let's start over. This time we're back to finding the equation of a line. Let's go back to find the equation. Find the equation of the tangent line to the curve, so to our graph. Our book likes to say to the curve, but that's our original picture, which is y equals x times the cube root of x. That is parallel to y equals 4x plus 8. Okay, so kind of like a problem I was just erasing. Instead of finding points, so we're back to finding the equation of a line. So we're back to finding the equation. But I know the slope. Just like horizontal, I knew the slope was 0. Same exact thing here because parallel lines have the same slope. Parallel lines have the same slope. So I know my slope. So I'm kind of going to do the same thing. But first I have to clean up this. X, and this means times the cube root of x. I don't like 2 x's, especially when I'm going to use my rules. When I'm going to use my rules for derivative, I need 1 x if possible. So this is, and notice this is still y. X to the first times x, the cube root, is 1/3. When you're multiplying, this is still y. When you're multiplying, you add exponents. So 1 plus 1/3 takes you to 4/3. 1 plus 1/3. Now I'm going to take the derivative. The derivative, which is going to give me slope. Roll it down. Subtract 1. Subtract 1, because now I'm actually doing my rules for derivative. Notice there's a big difference here. This is the same as this. I just did 2 different forms. So all of this up here was just changing the form. Now, I'm just going to move that just so that now I'm going to actually take the derivative, subtract 1. So that gives me 1. Just kind of like the last problem though. Okay, I know that this is going to find me slope, but parallel lines have the same slope. So I know that my slope is 4. So that just means I'm going to put it in over on this side. Just like I put the 0 over on this side on the last problem. I'm still, when in doubt, still take the derivative. Okay, and then think about, do I have the x or do I have the y? Okay. For this problem, I actually have the slope, which is fine. I can go find x. No big deal. Multiply by 3/4. Okay, so multiply by 3/4, multiply by the reciprocal. The 4's cancel, and so you have 3 equals x to the 1/3, and you can leave it like that. If you want to change it back to a cube root of 3, that might be easier to kind of reference. How do you get rid of a cube root? You cube both sides. And so 27, 3 cubed, 27 is equal to x. Okay, so let's just pause for a second. So I'm supposed to write the equation of the line. So I know that I'm going to do y minus y1 equals mx minus x1. Okay? I knew from the beginning this was 4. And I just found my x, so I know it's going to be x minus 27. So I need my y value. The point that I'm looking for is only on this curve. It is not on this. The only thing I take from this is the slope. So I have to find y. I must plug it back into my original. It's a point on the original graph. It is not a point on the parallel line. It is not a point on the parallel line. So I must go back to here. Y equals x, which is 27, times the cube root of 27. I must find the y on my curve, not on my parallel line. Right, so that gives us what? 27 times 3, which takes us 8. Maybe I should write this so that's what y equals. So when x is 27, now I have an official point, y is 81, which means I can put that right in here. That answer is fine. Again, for web assign, if they make us multiply it out, y minus 81 equals 4x minus 108. And then if we add 81, kind of weird, if we add 81, we just happen to get negative 27. Okay, so so what is this? That is fine. So that's the equation of the tangent line to this curve that was parallel. And how do I know it's parallel? Because it has the same slopes. And so I found the equation of the tangent line to our curve, and it's parallel. The only relationship with this line is that it's parallel, and I know that because that had a slope of 4, and this line has a slope of 4 also. Okay, then if you take your, take out your worksheet that I gave you yesterday, we want to just do a little bit with that. And before, you could probably write it here or in your notes, you have to write just a few things. You must remember that if a line goes up the page, it has positive slope. And if a line goes down the page, it has negative slope. Left to right. So when I say up the page, you must go left to right. Okay. All lines going left to right have positive slope. Going up the page, going left to right, if it goes down the page, it's negative. So up, positive, down, negative. You have to be going left to right. What else? A horizontal line has a slope of 0. If it's not very steep, okay, a flatter, we'll say flatter line, for lack of a better word, a flatter line slope is closer to 0. A steeper line has a big slope, okay, a big value. Slope is large. Slope is large, and I'm literally meaning the number. So let's do 2 lines real quick. So if I have, this is the black line,
We have a little partner with you today.
and this
So
is the blue line.
You can meet where?
Do we see how the black line has a flatter slope? And so it's closer to 0. Okay. And we can just make some numbers up. This is just arbitrary, but let's say this is maybe like 1/2, where the blue line is a lot steeper. And so its slope may be, 3, it may be 7, it may be 5. The steeper the number, which has a bigger slope? A slope of 3 or a slope of 5? A slope of 5 is a steeper line. 3 is steeper than 1/2. The smaller the slope, the flatter it is. The bigger the slope number is, the steeper the line is. Okay, so let's use that for these. So let's take out your sheet now. We got 2 problems. This picture is f of x. This picture is f of x. Tomorrow, we're going to do the picture of the derivative. The derivative graph is all the slopes plotted. Okay, so today these two problems are just going to kind of get us there. So the derivative is all the slopes plotted. Okay, so let's just talk about this one. I got this from a different book. And this I like. Plotting all the slopes is a little crazy. So we'll talk about that tomorrow. Now, this is f of x. Notice it asks for the derivative at 3. Or no, actually negative 3. Sorry, negative. It's asking for the derivative at negative 3. So if it's asking for the derivative at negative 3, it's asking for the slope on your original. So you have to go to negative 3. It wants the slope right there. How am I going to know what the slope is right there? But remember, it's also the slope of the tangent line. So actually go ahead and draw in kind of a tangent line here. Okay, now can I talk about the slope of that line? The slope of that line is the slope of that point, and that is what the derivative is asking for. The slope at that point or the slope of the tangent line. I think for this problem, all we have to do is decide, is that positive or negative? Well, it's a line that rises up the page, so it is positive. Okay. What about the derivative at negative 2? Well, derivative at negative 2 is the slope on the original graph. Notice this is f of x and this is asking for the derivative. So this is just saying, what is the slope at negative 2 on the original graph? What is the slope at negative 2 on the original graph? So if you look, negative 2 is right here. Okay. How do I know what that slope is? It's also the slope of the tangent line. So draw in the tangent line. Make sure I have that. What is the slope of that line? It's horizontal. It must be 0. Okay. And then let's try slope again. Remember, it's asking for the derivative, so slope at 1. So you go find 1. You want the slope of that point. So that's when x is 1. We don't care about the y, it's just when x is 1. Well, how do I know what that slope is? Draw in the tangent line. Because the slope at that point is also the slope of the tangent line. And I think all we have to do is decide that that is going down the page, left to right, so its slope is negative. So now it actually says, can you put it from smallest to largest? So it's actually the reverse, right? The smallest would be the negative, then would come the 0, and then last would be the positive. Negative, 0, positive. So they're just asking you to kind of look at the graph. Again, another way to remind you, derivatives are slope. Or derivatives tell you slope. Okay, derivatives and slope go together. All right, let's try this last one. Same graph, but since I have my tangent, I'm just going to erase it. Again, this picture is f of x. This picture is f of x. But then they talk about the derivative at 1. So that's just saying, hey, it's asking for the slope at 1. Okay? So 1 goes down here. Remember, you just x value 1, we don't care. You just go to the graph. We don't care where y is. You just want the point where x is 1. Whatever y is, we don't care about y. But not only do we find an x value of 1, but then we need to know the slope. The derivative is finding the slope. I think we just did that one, right? Its slope. Maybe I'll do the tangent line in red this time. Remember, how do I know what that slope is? Well, I draw in the tangent line, and then I can get a visual. Okay? And that is negative. You can write it if you want. Actually, I think I'm going to do it. Maybe not equal. I mean, it's negative. We don't have an actual value. It's negative something, but at least we know it's negative. Then it asks for the derivative or the slope when x is 2. Again, remember derivative says go to the original function, but give me the slope. How am I gonna know what the slope is at that point? It's also the slope of the tangent line. Draw that in. It's a horizontal. Must be a slope of 0. That one we can literally do equals. It literally is 0. Right? How about f of 5? Or the derivative of 5. The derivative of 5. Now 5 is maybe up here. How do I know the slope of that line? Notice, how did I go over there? Remember, you go over 5. And then you just go to the graph. We don't care about what. So go over 5. How do I know the slope? I had to draw on the tangent line. Looks pretty steep, but it's going left to right. It's definitely going up the page, so it is positive. I don't really have positive what, but I do know that it's positive. Okay, look at that. The red line has a negative slope. This black line has a positive slope. And that's always the case. Down the page negative, up the page positive. All right, and then you just give us a random number 0.1, which is 1/10. 0.1 is the same as 1/10. So this is negative. This is definitely going to be the smallest, and then comes 0. So we have these two numbers that we're comparing. So because they're both positive. They're both positive. This isn't necessarily a slope. They just gave us a random number, and they're telling us to put these things from lowest or smallest to largest. So, okay, this isn't a slope, but we have to think of it as a value, 1/10. Do we think that this line has a slope of more or less than 1/10? Okay. 1/10, if we talk about this in terms of slope, it would be up 1 to the right 10. Do you see how that would be very flat? Do you see how this is a lot steeper? Okay, I'm not going to guess. I mean, I could guess. I don't know for sure what it is unless I go find the derivative. But I know that it's a lot steeper than up 1/10. So I know the negative is the smallest. I know 0 comes next. And then my positives, I need the smaller one first. So that is the 1/10. And then I don't know exactly what it is, but it's pretty steep. So it's definitely bigger than 1/10. The slope at 5. Well, again, it's just kind of estimated. It's giving you another visual. It's a good, I think I do like this. The homework's a little bit harder, but I do like how this, you're seeing the tangent line, you're thinking about slope. You got to put together those tangent lines, slopes, and derivatives. That's kind of what has to get into your head. Okay, so you can finish section 2.3. So you can finish last night's homework, and you can do problems 1 and 2 on tonight's homework. Okay. We didn't get as far as I thought we would. Which is the story of my life, right? So we'll just address those tomorrow. And I think we'll actually do them tomorrow in class because I don't want you to have too much homework tomorrow. I want you to be able to catch up. So we will do some stuff tomorrow in class. We'll finish these, and then we have a few more notes to cover. But we should be able to get the homework done in class. So that'll kind of be nice. So come tomorrow, and then I'll help you through that. What else? Okay, so you really have 3 homework problems. Finish this one, which is really the last problem. I can't remember what number it is. But really the only new is do this if you haven't. Do the last problem, because now you know how to do that last problem. And then 1 and 2 on tonight. All right, have a good day.